All right, so let us continue. Number 30, women's heights are average 61 inches with the standard deviation of 2.7. They want us to use 68, 95, 99, 7 rule to determine the ranges of heights. That would be 99.7% of the women. All right, so that is one standard deviation. This is 2 standard deviations, and this is 3 standard deviations. Okay, if one standard deviation is 2.7, then what I need is to find the following. We need to find x bar plus or minus 3 standard deviations. Okay, 3 standard deviations for 99.7%. That's how we do it. Okay, so x bar in this example is 61, and I need to do 61 plus 3 times 2.7, and 61 minus 3 times 2.27. So this is what I need to do. 61 minus 3 times 2.7. That'll be my first number. My second number is 61 plus 3 times 2.7. All right, so 61 minus 3 times 2.7. This is a 0.7. Is 52.9. Then 61 plus 3 times 2.7 is 69.1. So that is the range for 99.7%. Okay. 30, 31, I worked for you. Should be pretty straightforward. It's basically the 68, 95, 99, 7 rule. 68% is within 1 standard deviation, 95 is within 2, and 99.7 is within 3. 32, I answered for you. Number 3, I might need some extra paper on this one. The scores on tests are normally distributed with a mean of 50 and a standard deviation of 10. What is the score that is 2.5 standard deviations below the mean? All right, well, there's a couple of things we could do here. I'm going to use my z-score formula. Z equals x minus x bar over s, where that's my z-score, that's my element, and then that's my mean and my standard deviation. So let's see what we got. The mean is 50. My standard deviation is 10. And then this says, what is the score that is 2.5 standard deviations below the mean? Well, 2.5 is 2.5. And if it's below the mean, then it's negative. So that's my z-score. Okay, below the mean means negative. 2.5 is just 2.5. So I'm going to solve this for x. Minus 2.5 equals x minus 50 over 10. I'm going to show this in fewer steps. We did something like this in the notes and the homework videos. So this is minus 25. What I did, by the way, is I just multiplied both sides by 10. And I get x minus 50. I'm going to add 50 to both sides. And I get x equals 25. Okay, so 25 is my answer. Okay. 34. So we got the 68, 95, 97.99.7 rule. We got this diagram here. Anytime I see this, you could, since you won't be able to print out the test, you can you could kind of sketch this out and then highlight what I'm going to highlight. But they tell you the mean is 20,000, so that's the number here in the middle. And then the standard deviation is 500, so I'm going to add 500 each time, subtract 500 each time. The question is, basically find the percent of folks between 18,500, okay, there's 18,500, and 20,000. Okay. So we have a table, we have a chart that we filled out. I think I'll show you that. Now, when you get to the test, if you want to create this after you've started the test on your scratch paper, you can. You may have memorized some of these values. But this is on here, this is where I'm about to get these values. So this number is right outside of the mean, so that's 34. 34. I'm just going to add up each of these numbers. Oh, you can't see what I'm doing. And then we go out here, so that's 2.35. So I'm going to add up all of those numbers. Okay. 34 plus 34 plus 13.5 plus 2.35. 34 plus 34 plus 13.5 plus 2.35. Let's see here. Did I make a mistake? I did, look. I put my extra bar there, so let me fix it. It's here, 20,000 here. So in my calculation, I added an extra 34. Okay, so I should have only had 34, 13.5, 2.35, and that gives me 49.85. Yeah, those are small numbers, so I got to pay attention. All right, let's see. The scores on a GRE test are normally distributed with a mean of 591. That means X bar is 591. And a standard deviation of 136. Use the 68, 95, 99.7 rule to find the percentage of people taking the test who score between 1319, 319, and 863. So what I want to do is I want to figure out what, if my mean is 591, I want to know what happens if I go one standard deviation out. Okay. What happens if I go one standard deviation out? Which means I'm going to do 591 plus S, which is 136. And then I'm going to do 591 minus that. Okay, I got 727. I'm going to subtract 591 minus 136. With 455. So This 319, 863 means I probably need to go another standard deviation. So I'm going to take my 727, add another 136. Okay, here I went 591 plus 2 times 136s to get that. And here I did 591 minus 2 times 136. You get that 319. All right, so that's how I can get the 319 and the 863. The fact that they tell me to use this rule means that's going to work out. I may have to go 1, 2, or 3 times. So this was 68%. This, let's go down here. If I go 2 standard deviations, that's 95%. Okay, so that's what we did. We used all of this, which is 95%. We went 2 standard deviations. Okay. Well, at least on that question, it's kind of multiple choice. All right. Same kind of question. We're still talking about the GRE. So we'll probably have to do the same thing. Scores on a GRE are normally distributed with a mean of 542. So X bar equals 542. And a standard deviation of 86. Use this rule. So that means draw a picture. And they want to know the percentage of below 284. All right, so first we got to find where 284 is. We know our mean is 542. Okay, since we're going to be lower than that number, I'm going to first try to subtract 1 standard deviation. 284 minus, oh, I'm sorry, it's 542. 542 minus 86, okay, that's 456. This is 1 minus a standard deviation. I'm going to go another standard deviation. That's my 370. Okay, this was X bar minus 1 standard deviation. This was X bar minus 2 standard deviations. I'm going to have to extend this out. Okay, if I go 3 standard deviations, I get my 284. Okay, so this was X bar minus 3 standard deviations. They want to know what percent is less than that. Okay, that's not much. But if I look at my picture, which again, you can draw after you've started the test, if I go out 3 standard deviations, 1, 2, 3, then 0.15% is all that is left. So less than is 0.15%. Okay, so not much. And if you draw the picture, you'll see it can't be much. All right. Number 37. Set a data items normally distributed, mean of 40, standard deviation of 7, convert 26 to a z-score. Well, probably need some paper. So, the z-score formula, x minus x bar over s. All right, for this one, they say the z-score is we're looking for the z-score. I'll do it right here. Z is equal to x, so that's our data item, that's our x. In fact, I might just label what I know first. We know the mean x bar is 40 and my standard deviation is 7. So I might write out what I know and then put it in the formula as I work it. So 26 minus 40 is minus 14 over 7, which is minus 2. That's it. If it wants us to round, we round. Okay. Let's see, scores on a dental exam. A dental anxiety scale range from 0 to 20. The scores are normally distributed with a mean of 11, well, that's some important information, and a standard deviation of 4. Find the z-score for the given score. So that given score is our x. Okay, so again, we're just looking for the z-score. So z equals x minus x bar over s. Z is 4 minus 11 over 4. 4 minus 11 is minus 7 over 4. It says to type an integer or a decimal. So we do need to find the decimal. Okay, so we get minus 1.75. If they don't tell you to round it, that means that number better be like a nice complete decimal. Alrighty, so let's look at number 39. This is the IQ test question. Okay, we're comparing the two scores, test A and test B. So test A, test B. So I'm going to make kind of a chart, not a chart, but I just want to separate the information for test A and test B. Test A has a mean x bar of 100 and a standard deviation of 18. And then test B has a mean of 100 and a standard deviation of 16. All right, now we got to see which of these two scores are better. Somebody who scores a 127 on test A or a 126 on test B. Okay, so even though 127 is higher than 126, it really relates back to which one has a better z-score. So z of test A is what I'll call it, is x minus x bar over s, so z of A. You don't have to do z sub A, that's just me reminding myself which one this one is. 1.5. Okay, so I get 1.5. I want to see what happens to this one. So z sub B. 126 minus 100 over 16. Okay, that's 26 over 16. So 26 divided by 16 is 1.625. So we look at those two numbers. Either this one's bigger than this one, or this one's bigger than this one, or they're the same. Since B is bigger, then if you make a 126 on the IQ test, you actually have a better score. Okay. Okay, we'll probably do number 40, and then I will do stop this video. No, we might keep going. Let's see. All right, so a set of data items is normally distributed with a mean of 400, X bar is 400, and a standard deviation of 10. Find the data item. All right, if they say find the data item, that is X. So I don't know what X is. And they tell us Z is equal to 7. Okay, so we're going to use our formula, but we got to do a little bit of algebra to do it. So the Z formula is X minus X bar over S. I'm going to put in what I know. Z is 7. X we do not know, so I leave it as X. X bar is 400. S is 10. So I'm going to solve this using some algebra. So we're going to multiply both sides by 10. We get 70. Since I multiply by 10, my fraction on the bottom goes away. And if I add 400 to both sides, then I'll get 470. So X is 470. Okay. All right. Number 41, we're starting to use our Z-score table. So let's see. I guess we'll go ahead and do this one since we're on this page, and then we'll probably stop after that. Yeah. All right. In a certain study, women's heights are found to be approximately normal with a mean of 64 and a standard deviation of 2.5. All right. I think I might want to write some of this down. Mean of 64 and a standard deviation of 2.5. What would the Z-score be for a woman who is 5 feet 10 inches tall? Z-score, okay. So for part A, I need to do X minus X bar over S. Now the problem here, 5 foot 10 inches needs to be converted, okay? So 5 feet, there are 12 inches in a foot. So to convert 5 foot 12 inches, we need to convert the feet. So that's 5 times 12 plus 10, which is 7. That is going to be our X. Okay, that is our X. So let's use our formula. Z equals 70 minus 64 over 2.5. 70 minus 64 is 6. Divided by 2.5 is 2.4. Okay, they say round 1 decimal place if we need to. In this example, they were nice and the numbers worked out. So now I have to look at my Z-score table. And this is a big one, but what I need to do is look for the 2.4. Okay, I'm going to highlight it. And then the number to the right tells us what percent she's taller than. This means that 99.18% of scores or items are less than this one. Had it been what percent is taller than her, we would have to do 100% minus this number. But because we're looking for things less than, that corresponds to 99.8%, which is like a lot of stuff. Z-score of 2.4 means that 99.18% is less than that Z-score. Okay, so we're going to stop the video there. This is probably a long one.